Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. As I stated at the outset of this series, half of the battle to learning to develop software is learning the C# syntax itself, and the other half of the battle is learning how to utilize the .NET Framework class library. Now, we've seen the .NET Framework class library, and we've been talking about it. It actually has a second name that it's known by, the base class library. And I'll explain why that's actually a really interesting way of describing the library as a series of base classes. So we're going to talk about base classes in this lesson, and specifically inheritance, what it is, how to harness it, and so on. Okay, so using the technique that we've learned previously, we're going to create a new console application called Understanding Inheritance. And the very first thing I'm going to do is start with that car class like I've used previously. I'm going to paste it in here. I'm going to add quite a bit to it. Now, if you need to catch up, pause the video. Make sure you follow along, whatever you do, all right? We're going to add a lot of code in this lesson, so get typing. All right, we're also going to create a helper method here, and we haven't created this particular one before. This time it's going to be a private, actually I take that back. It's going to be a public string format me will be the name of it. And we're simply going to just return a string.format, and we're just going to make a string pretty. So, you know, depends how you define pretty, I guess. We're going to format it. That much I can promise you. And again, same line of code. We're just moving to the next line here. So we'll start with a make. We'll show the model. We'll show the color. And we'll show the year. Great. Awesome. Okay, now that we have a fully fleshed out car class, let's go ahead and create an instance of it. Let's populate its properties, and then I want to print that format me to screen. Okay, so I'm going to actually start off simple. So here we're going to go car, my car equals new car. That much we understand. And then we'll populate all the properties like the make. We'll set it to BMW. I wish my car was a BMW, but it's not. Model. Set it to 745 Li. My car dot color. Set that equal to black. And then 2005. All right, now I'm going to create a helper method that belongs to the program class. So it's going to be a private, and we'll talk about private and public later, private static void print car details, and I'm going to allow the user of this helper method to pass in a car, and then we'll do console.writeLine. Here are the car's details. 0, and what will we pass it? Car.formatMe, like so. Awesome. All right, just to make sure that we've typed it all in correctly, I'm going to go ahead and run it real quick. Whoops, something's not quite right. Oh, I forgot one key ingredient, actually two pieces. I did this when I was preparing this too. Okay, so let's call the print car details and pass in my car. That's the first part. And then console.readline, like we do in every single application we build. Now let's test it. All right, that's exactly what I wanted to see. Awesome. Hopefully everything that I did here makes sense to you, and we don't need to review any of this. If something didn't make sense, you probably weren't watching the last couple of lessons closely. I'd recommend that you go back and rewatch some things. All right, make sure that you understand what we've done so far. Okay. All right, so let's suppose for a moment that this application works great, and the car class is great for cars, but suppose that we need slightly different functionality whenever we're working with trucks in our application. So in some ways, trucks and cars are the same, And in some ways, trucks and cars are a little bit different. I suppose I could create a second class that's called truck, and I can make it almost identical to the car class in every way except for the properties and methods that are different. I could merely copy and paste and just change the word car to truck, and I could be on my way, right? Well, if I do that, I got a couple of potential problems. First of all, it violates one of our rules to never write the same code twice, and worse, never to copy and paste code, right? But let's suppose we actually typed it in. It's not just a matter of having twice as much code to maintain, although that certainly will be the case. If we copy and paste the code and it's buggy, then we're going to need to fix the problem in 2 or more places. Or if we rewrite the code from scratch, that's essentially performing the same logic. However, we weren't careful and the logic is inconsistent, then we'll need to fix the logic in 1 or more places. And so from experience, I can tell you that that's a bad situation. Second, our application might need to deal with both car objects and truck objects. Will we have to create 2 versions of every single method that accepts car as an input parameter? I mean, look at this. If I had to create a second one of these helper methods that only dealt with trucks, because I've got a car class and I've got a truck class, and now I've got to create, and now I create one for motorcycle, and I create one for boat, and I create one for semi-truck, and I create one for submarine. I don't know. Now I've got all these helper methods that are so, specific to one type. There's got to be a better way than that, right? So that'll quickly become unwieldy, again, if we need to add different types like motorcycles or other motorized vehicles. So ideally, we could merely borrow the things about a car that make sense and then override the parts of the car class that don't make sense for a truck or a motorcycle or whatever the case might be. Things that cars don't really need, like the bed size and the towing capacity and other truck type of things, okay? But we can do this by creating a truck class and then making it inherit from the car and then adding the properties and methods that specialize the truck. Now, because a truck is different than a car in some small ways, at least in our application, then I'm going to specialize the truck class by adding another property. So here's what we're going to do. Let's go outside of the car class, right here, and we're going to create a new class called truck, and then I'm going to use the colon and then use the word car. That says I'm going to inherit from the car, and now I'm going to use prop tab int towing capacity. Enter, enter. Awesome. Okay, now let's go up here to the very top, right before the read line, and we'll create a new instance of this truck. So truck, my truck, equals new truck. And then I'm going to go my truck dot. Now I want you to notice this in IntelliSense, what you see here. Because truck inherits all the properties and methods of the car, color, make, model, towing capacity, year, and our format me method, they all appear as available to the truck, all right? And so, and then also the towing capacity, the new property I added just to the truck, appears here as well. It's awesome. So let's go ahead and finish this code example out by giving the truck some details. So let's set its make equal to the Ford. Let's set my truck dot model equal to an F950. My truck dot year equals a 2006. My truck dot color equals black. My truck dot towing capacity equals 1,200 towing units. I don't know. I don't know what a towing capacity unit is. All right, but so we can access the towing capacity property from the truck. What if I try to access it from my car? It doesn't exist, at least in IntelliSense. Towing capacity equals 1200, and I'm going to get the red squiggly line. It says it doesn't contain the car doesn't contain a definition for towing capacity. All right, so can't do that. All right, so specialization means that we get all the features of the car and we add key features that are unique to the truck. They're not available to the car, only available to the specialized version of the car named truck. All right, so there's a bunch of benefits to inheritance. The most obvious is that you can save a lot of code, right? I mean, all we had to do was just say we're going to inherit from the car, and then we're just going to add one property to it, like so, right? So another one that's not so obvious is that anywhere a car would work, like as an input parameter to a method, truck will work as well. So let's do this. Let's call our print car details, and I'm going to pass in my truck. All right, so let's start running the application. And so you can see that here are the car's details with the BMW, but here's the car's details the second time. It has the Ford F950 Black 2006. All right, so how is this even possible? It's only possible because truck is a type of car. And there's quite a bit of different terminology that I could use between a type of or a version of type syntax to describe that relationship now between the truck and the car. For example, the car class is referred to as the base class, and the truck is referred to as the derived class. Or you might see the terminology that says the car class is the parent class and the truck is the child class. Or you might see the terminology used like this: the car class is the superclass and the truck is the subclass. All of those terminology usages work, and you'll see them commonly throughout writings depending on who's doing the writing and what terminology they prefer. But they all mean basically the same thing, okay? So how does this apply to the .NET Framework class library or the .NET Base class library? Well, our purpose in this lesson, again, is to explain how the .NET Framework class library, the base class library, is just one massive collection of all these base and derived classes. Why? Because it creates this flexible way of working with classes in the framework. One example, and there are many similar examples available, but just picking one, what I want to do is pick on the stream reader class that we saw from the Read Text File WOW project back in lesson number 11, I think. So the stream reader class utilizes functionality that's defined in the file stream class because stream reader derives from file stream. So let's do this. Let's open up Internet Explorer, and I want to go to a page on MSDN. And so every single class in the .NET Framework class library, in the base class library, it gets its own page on MSDN, and it tells us things about that class, its inheritance hierarchy, which we'll come back to in just a moment, the syntax used to define it so that you can see how it's defined, all of its constructors, its properties, its methods, all right? Things we've already learned about, right? Previously up to this point. Well, that's the file stream class right there. And some remarks, some example code, how to call the file stream class, and other related information. All right. And so as you're looking at this, you can see that we're on msdn.microsoft.com. It's Microsoft's developer network. It stands for the Microsoft Developer Network, which contains many resources for developers. Most importantly for our purposes, it contains a page describing each class in the .NET Framework class library in the standardized format that I just pointed out a moment ago, including a brief explanation of the purpose of the class, along with its inheritance samples and so on. All right. So we see here that the file stream has this inheritance hierarchy here prominently displayed on the page. You can see what a given class derives from, as well as what derives from it. And you can see that it goes back several generations, if you will. So in this case, file stream inherits from system.io.stream. And if we go back far enough, we can see that it inherits from system.object. In fact, every class in the .NET Framework class library ultimately derives from system.object. So if I click on the link to investigate the system.io.stream, as you can see, the stream class provides a generic view of a sequence of bytes. And then it says also that it's an abstract class. So now whenever we're working with the stream reader, we're working with a sequence of bytes that were stored in a file. And if we were to click the More right here, we can see at the very bottom of this page all the classes that derive from or are children of the system.io.stream class. And so we see our file stream class down here, but it has a number of siblings. Each of these derive from the same base class, system.io.stream. In other words, they all work with streams of bytes, even though how they work with those bytes might be dramatically different. Some will work with streams of bytes in database data like Oracle or SQL Server. Some will work with zipped files, so bytes that are stored in zip files. Some with bytes that are streamed over the internet, and much more. You can see just the names that they kind of lead you to understand what those particular classes are used for. So what I understand when I look at all this is that these classes will help you work with bytes of data. They're all similar in how they work because they all derive from the same parent, the system.io.stream class. But the way that they work internally and what they do for you is just a little bit different. So from a practical standpoint, once you learn about how streams work in general, you can expect similar behavior as a user of these various stream classes that you see here. So instead of just memorizing the specifics about each class, you can kind of fumble your way around by associating the things you know about stream classes already to a new usage of a new stream-based class that you see in this list. All right, so inheritance is a core concept in the .NET Framework class library, and it helps those who are consuming the library to get their head around some of the inner workings of similar but different classes. Right? All right, so let's move on. Let's go ahead and close this down. Actually, I'll just minimize it for now. So as you can see in my format method right here, in my car class, suppose there's something different about the format me method that simply won't work for trucks. After all, at the moment, its formatting is geared specifically towards cars. There's no understanding of the concept of towing capacity, for example. All right, and we want that whenever we want it printed to screen. So this simply won't work for trucks. After all, at the moment, it's just formatting for cars. So not to worry. What you can do is override the implementation of this format me method by using the override keyword in the derived class, or rather the child class, or truck class in this case, and then using that same method name and signature like so. So let me just go ahead and copy all this. And I'm going to paste it here. I know, copy and paste is bad. Don't use my own words against me here. All right, so let's remove this, and we're going to call this towing units. And then instead of this.color and this.year, we'll change this up to be this.towing capacity, like so. All right. So we're not done at this moment. We actually have two other things we need to do. First of all, we need to say that we want to override this format me method. We want to override the default implementation of format me, number one. And then secondly, to make this work, we're going to need to add the virtual keyword to the car class's format me method declaration. So here we'll go public virtual string format me. So virtual means, hey, if you want to override me, go ahead. I'm fine with that. And if you don't, that's fine too. I've got a basic implementation for you that you can already use. But if you need a specialized version, well, just go ahead and do your own, okay? Which is exactly what we've done here with the override keyword. So virtual says, go ahead. If you want to override me, you can, but you can also just rely on this base implementation. And then the override says, yeah, I'll take you up on that. I want a different version of format me for my own purposes. Okay. So now when you run the application, you're going to see the result of two different implementations. Here in the second listing, or the second item, we see the 1,200 towing units now formatted correctly. Great. Okay. Let's move on from there. So we can also change the declaration from this virtual keyword to this abstract keyword, which means you must change it. So you're saying, hey, if you want to derive from me, that's cool, but you have to change this method to suit your needs. I'm not going to support anything that you come up with. You got to do it on your own, all right? So now using abstract is not appropriate in this particular context because we still need to define an implementation for the car class itself. But that does bring up a bigger issue. I mean, maybe we shouldn't derive a truck specifically from car. That might make sense in some applications, but in our case, maybe instead it might make sense for both car and truck to derive from a base class at a higher level. So maybe we can rework our code so that they both inherit from a special kind of class, what we're going to call an abstract base class. Okay? So in this case, simply deriving from car might not be quite the right option for the truck class. Some properties and methods available in car might not be applicable to the truck, but we still get those anyway, all right? So admittedly, in this simple example, it really shouldn't matter. But what if we had a more complex scenario? There might be some things about the car that doesn't apply to the truck, all right? And so that's what we're trying to work around. So in these cases, the best thing that you can do is just back up a little bit and create a special type of base class called an abstract base class. The difference between a regular base class, like we've demonstrated so far, and an abstract base class is that you cannot create an instance of an abstract base class. The only way that it becomes useful is when there's a concrete version of the class created. This is exactly how the stream class that we just looked at worked. Back in MSDN, scroll up here to the top. Oh yeah, here we go. Notice that I kind of passed over this quickly, but this is an abstract class. So stream is an abstract class. Furthermore, if you continue on and you look at its properties, you will see each of the descriptions for those properties begin with the words when overridden in a derived class. So in this case, a stream is just a concept, and the way that it's defined, it's simply a template. Not something that you create an instance of, but something that you embrace and extend. I don't know if I can use that phrase. It's something that you actually say, I want to be like that, but here's my implementation of it, okay? So if we then scroll down, however, and we look at all of those classes that inherit from system.io.stream, we can see again here, file stream, if we go there, the file stream is concrete in so much that it's an implementation of the stream abstract base class. Just a pattern saying, I promise I'm following, I'm inheriting from that abstract base class. I get all of its functionality, but you can't just create an instance of stream. Stream is meaningless. It's just a concept. But a file stream is something concrete that you can actually do something meaningful with. Okay? That's all we're trying to say here. In the example that we've been using up until now, we might choose to create a vehicle abstract base class and then have both the car and the truck and even other vehicles in the future, such as a motorcycle, boat class, or whatever the case might be, inherit from that vehicle abstract base class. So introducing a new abstract base class is going to cause ripples throughout our entire code base that we've created up until this point. So let's take a few moments and work our way through some of these ripples. So I'm going to start here by creating a new abstract class vehicle. I'm going to take all these properties. I'm going to give them the vehicle. Okay, when you do this, notice you're going to break a lot of stuff. We'll fix it all before we're done, okay? And now I'm also going to create a public abstract string format me. Where's the implementation of format me? It doesn't have an implementation. Again, you can't create an instance of an abstract base class vehicle, but we can say you have to have an implementation of format me whenever you derive from vehicle. Let's move on. Now, car is going to derive from vehicle. And let's see, everything else looks good there. Awesome. Let's move on to truck. Truck no longer implements car, it's going to implement vehicle. It also has a towing capacity. It also has public override string. That reminds me, I'm going to need to change this from abstract to override now, right? Because the abstract format me has already been defined here. Now we're just overriding. All right, so now let's go back up here to the top. Notice that we have a problem with one of our lines of code. The print car details, where we pass in, the version that passes in my truck, it no longer seems to work. When I hover my mouse cursor over it, it says the best overloaded method match for print car details has some invalid arguments. Why is that the case? Because truck is no longer a type of car. Truck is a type of vehicle. Car is a type of vehicle. So what are we going to have to do to make this work? Well, the semantics of the relationship have changed from parent-child to sibling, and so to make this work, what we're going to need to do, first of all, is we're going to need to change this from car to vehicle. And I think that at this point, we're going to need to change the name of this because it's denoting that it's only working with cars, and that's not true anymore. So let's change this to print vehicle details. Of course, that's going to break everything now that used to call the car version, so we're going to need to change that in a couple spots too. I was going to show you another feature, but I already went past it. Never mind. Okay, great. All right, finally, I see I have one more problem in my code. I used to refer to the input parameter called car, but now I'm going to have to change that because the input parameter's name is now vehicle. Whew. Also, in the string that's going to print out the details, I'm going to need to change this from saying cars details to the vehicles details, just to make it semantically correct. All right, so now when I run the application, I see here are the vehicles details, BMW, second one is Ford. We're great. Okay, so hopefully you understand why we did that and what the purpose of the abstract base class is. First of all, the abstract base class allows us to say you have to implement these things, and here's even implementation of some properties, and here's some methods that you need to go off and create yourself. So it creates a pattern for us in a sense that we have to then implement in any of the derived classes. And the reason why we want to do that is so that now we can use that vehicle class and create more derived versions of that class, motorcycle, boat, whatever the case might, ski-doo, okay? And yet they'll also work as long as we implement that format me method. Okay, great. Let's move on. So the antithesis, the opposite of the abstract base class is a sealed class, meaning that you cannot inherit from it at all. All right? So you might never want another class to be able to inherit from your class. And so what we can do is mark it as sealed. So in this case, we're going to call this class truck a sealed class truck. Now, nobody can ever, not me, not anybody else, can ever create a new type of truck. So let's say, for example, in the future, I come in here and I want to create a semi. And I'm going to say it's of type truck. And here we go. We're going to specialize truck with something called a semi. We'll give it the number of wheels, like 18, and so forth. But when I try to go and build the solution, I'm going to get an exception. Cannot derive from the sealed type, understanding inheritance truck. All right? Now, why you might want to do that is because you don't want anything to be able to create new versions. You don't want that inheritance tree to go on and on. You want to stop it right there. The reasons why you might want to do that may not be clear at this point. I'm just showing you the tactic, the technique for doing this. The reasons why are going to get back into some of the things that we talked about in our previous lesson with regards to a larger understanding of object-oriented programming. For our purposes, just know that there are sealed classes defined in the .NET Framework class library, and that's why you won't be able to create your own versions of those classes. Okay? So when you work with classes in the .NET Framework Class Library, be aware that almost every class is part of an inheritance hierarchy. If a class has a method or properties which are not readily apparent, it might be because it's inheriting the method or the properties from a base class or even an abstract base class. You might learn a lot about a given feature of the Framework Class Library if you simply stop, take a moment to understand a little bit more about its parents or its siblings or even its children that inherit from it. Oh, I'm not supposed to use this class. It's merely a base class for all these other specific implementations. Silly me. Okay? So you can certainly utilize inheritance in your own projects, but frankly, that might be down the road a little bit for you from this point. If this is indeed your first attempt at learning how to program, regardless of the programming language. However, perhaps you'll work on a large project in the future where it makes sense to create some library of business rules and logic that can be applied and shared across the entire application or a family of software applications. In those cases, you'll undoubtedly be in need of a good inheritance strategy. And again, there are good design patterns for properly utilizing inheritance in your application designs, but for now your focus is probably going to be consuming and utilizing libraries that were created by others, like the .NET Framework Class Library. The other takeaway from this is that there are a number of C# classes and method modifiers that the creators of the Framework Class Library have used in an effort to guide you whenever you're trying to consume their classes. And by that I mean that they create abstract base classes or seal classes or even use other modifiers in an effort to help nudge you, the consumer of those classes, in the right direction and prevent you from doing something that would break those classes or use them in an unintended way. All right, that's one of the reasons for the sealed keyword, just so you know. So it forces you to use them in the way that they were intended to be used. It's just a matter of realizing, oh, I can't create an instance of it because it's marked as static, okay? Or, oh, I can't derive from this class because it's marked as sealed, right? So once you understand a few of those key terms and you look them up on MSDN and you're able to interpret whatever MSDN has to say about it, and you understand what you're supposed to do with a given class in the Framework Class Library, or what your options are, then things will start clicking for you. You'll start being able to understand how to really utilize everything that the Framework Class Library offers you. Okay? So you're doing great. This is meaty stuff. Don't let anybody fool you. Getting your head wrapped around it is a challenge, but you can do it and you're doing great. As long as you understand the basic concepts here, we'll keep building on those in the next lessons, and we'll see you there. Thank you.